Thank you so much. So once again, I will try to be brief because I think we are very behind the schedule. And since we are at the biggest railway fair in the world, the last keynote will be much more oriented towards the railways because we are extremely convinced that, especially in Europe, Hyperloop has to happen together with the railways. And what we are proposing is a sort of a bridge solution between the conventional rail and the Hyperloop, because we deeply believe Hyperloop is the future of guided transportation, but it should not be offered as something contrary or an alternative to the railways. And we also are very much convinced that interoperability between railways and Hyperloops is the key. So starting a bit with railway issues, the core thing that drives railways is almost 200 years old. We're talking about a steel-to-steel interaction, which is great for cruising speeds, but it's not really great for tractive efforts because it's very low friction coefficient. If you want to accelerate, if you want to brake, it simply doesn't work so well. So what we propose, and I'm going to speak about it on the next slide, is to exchange it to a contactless mode of propulsion by a linear motor, which is, of course, heavily Hyperloop and maglev inspired. And then we could have probably endless discussions with Carlo about it, how much efforts are being made to improve this very analog interface, right? With, for example, DAC and other technologies. But then we still think that if we don't solve this basic traction issue with something modern, something digital, it's like the railway system itself will never reach the full performance potential because it's simply the biggest limit. And then something that will be also kind of applicable to Hyperloops, adding new capacity because of the previous two issues for railways takes quite a lot of time and a lot of money because we need to build new infrastructure. So what we proposed in 2018 was to reuse existing railway infrastructure, which is perfectly located. The land beneath it is worth simply billions. This is the only high-speed infrastructure that has access to city centers. And to give it another life in such a way that once Hyperloop gets there, it can be all connected. So for example, we will not have to do the tunneling to the central stations for Hyperloop, but we can use an adapted railway line to do like the kind of last mile service for Hyperloop traveling between city outskirts. So we use a linear motor propulsion, magnetic levitation, which can be there, but it's not necessary. And we are very much focused also on power electronics and IoT solutions to better control and maintain the system. And the overall goal is also to make the Hyperloop implementation easier. Because if we prove that some subsystems work in the conventional environment, where the land is already there, it's just faster to do it, then it's also a proof of safety for further expansion of the system. So we offer two intermediary solutions. The first one is called Magrail Booster, and David, we can have a discussion which booster was first, maybe after. But this is still using conventional rolling stock with an added linear motor mover and the stator between the rails. And here it's mostly about flexibility, so being able to run single wagons, single cars, and adding a lot of capacity. And the second version, requiring new vehicles, lighter ones, is a levitating Magrail, again integrated with a conventional infrastructure. And the third step, which can be achieved in many ways, it can be greenfield project, it can be a transformation of Magrail lines. This is a full Hyperloop, and our big objective is to make all of these three interoperable with our propulsion suspension subsystems, so that we can avoid the fate of maglevs, which, because are not interoperable, haven't got so much proliferated around the world. A couple of use cases. We are quite convinced that the booster for freight can be a really good solution to accelerate ports, to accelerate trains on inclines and so on. Then upgrade to a full Magrail of existing lines. For some greenfield projects, it can be a pure solution without conventional trains, but this is like optional. And then, of course, Hyperloop. Martin mentioned this first tests that we did in Warsaw in 2019 on the left hand. Then the model, the next one, the orange one, you can see here at our booth in Hall 4.2. This was in 2021, and now we have already finished building a full-scale test track in Poland, 720 meters long. And we are just waiting for some final components for power electronics to be fully tested and shipped there, and we're gonna start testing. Soon this is the levitating version, and in cooperation with RFI, hello Giuseppe, we are planning to do a much bigger testing facility in Bologna San Donato. Here are a couple of pictures of our track modernization and how it looks. And to wrap it up, we are very much convinced that the whole Hyperloop industry, and this has been said by everybody earlier today, should very much join forces. And we are also very much convinced that we should join forces with railways in order to make the system more efficient, more interoperable, and be able to implement it faster to reach these objectives of having as many lines operational by 2030 as possible. Thank you so much.